Hello friends, welcome to Learner's Planet. Friends, this is our second session for linear inequations. In the previous session, I discussed the very basic things about linear inequations, and we discussed intervals also, closed interval, open interval, closed open, open intervals. Okay. In this session, I'll introduce linear equations, linear inequations in fact, with one variables and two variables. Okay. So let's begin this session. So what exactly a linear inequation in one variable? Just listen to me carefully, and we just see here. Let a and b are non-zero real numbers and x be a variable. Then inequalities of the form ax plus b is less than 0 or maybe less than equal to 0, greater than 0 or greater than equal to 0 are known as linear inequations in one variable x. Okay, examples are given over here. 9x minus 15 is greater than 0. Here we can see greater than sign. This is greater than equal to sign. This is less than sign, and this is less than equal to sign. Okay, so 9x minus 15 is greater than 0. How do you solve it? Simply 9x is greater than 15. That means x is greater than 15 by 9. Okay, so when x is greater than 15 by 9, that means x is not equal to 15 by 9. There is a difference between greater than sign and greater than equal to sign. That I have already explained in the interval session. Okay, so be very clear about it. Here suppose 5x minus 4 is greater than equal to 0. That means 5x is greater than equal to 4. That means x is greater than equal to 4 by 5. I'm just putting some examples over here. Detail of the same I'll explain later on. Okay. Similarly, we can see linear inequations in two variables. Earlier we were having just one variable, that is x, so we call it linear inequation in one variable. Now suppose we have two variables, x and y, then a combination of two variables and some relation between them is linear inequation in two variables, right? We are using the sign of inequality over here. Now a and b non-zero real numbers and x and y are variables, then inequations of the form ax plus by is less than c, less than equal to c, greater than c and greater than equal to c are known as linear inequation in two variables. Examples are given over here. 2x plus 3y is less than equal to 6, greater than equal to 12. Here we can see less than sign and greater than equal to. Okay, so that's very simple. A linear equation in one variable, you just have one variable, and in linear equation in two variables, you have two variables, right? Pretty simple. And you must be knowing the meaning of all the inequalities, right? Greater than, less than, greater than equal to, less than equal to. Okay, some words are used, maybe at least, at most, right? Not more than, less than, not less than. So various phrases are used to represent the sign of inequalities. You just have to apply common sense, nothing else. At least, that means minimum, right? Suppose I say you, I want at least 5 chocolates. At least 5 chocolates. That means I want 5 or more, right? So my chocolate should be 5 or more. Okay, so that's pretty simple. At most 5 chocolate, that means my chocolates must be less than, at most it should be 5. So less than equal to 5. Okay, so that's pretty simple. Not more than that, not more than, that means at max, at most or not more than. Both of them are same. So it's very general, you can say knowledge is here. General like sense is here. There is not much deep mathematics involved over here. You have to apply common sense, nothing else. Okay. So friends, as we have linear inequation, we may have quadratic inequations also. Okay. So if a, b are non-zero real numbers, then an equation of the form ax square plus bx plus c is less than 0, or ax square plus bx plus c less than equal to 0, greater than 0, greater than equal to 0, known as quadratic inequation. Okay, so how to solve quadratic inequation, that will discuss in the chapter functions. Okay, that is discussed in the chapter functions. In this particular topic, we'll be discussing only linear inequations in one variables and two variables, right? So let's see how do we solve a linear inequation. Now friends, we see the basic rules of solving linear inequations in one variable. Okay, same number may be added or subtracted from both the sides of an inequation without changing the sign of inequality. Okay, we'll be taking examples also. As of now, just read out the rules. Both sides of an equation can be multiplied or divided by the same positive real number without changing the sign of inequality. However, the sign of inequality is reversed when both the sides of inequations are multiplied or divided by a negative number. Any term of an inequation may be taken to other side without its side changed without affecting the sign of inequality. Okay, first we take a very simple linear inequation with just one variable, right? I just take x minus 3 is greater than 0. Okay, now what is happening? What you can do is, without changing the sign as it is mentioned over here, any term of an inequation may be taken to the other side with its sign changed, but without affecting the sign of inequality, right? So suppose if it is equal to over here, what you do? X is equal to 3. So in this case, what you have to do, just x is greater than 3. Just take minus 3 to that side. So this minus will be converted to positive 3. Minus 3, positive 3. So x is greater than 3. Okay. Now suppose you want to put a negative sign. See, x is greater than 3. That means what? X. Suppose I draw a number line to make this concept easy. I draw a number line. Here it is 3, 4, 5, right? So x is greater than 3, that means x start this way. Okay, now if x is greater than 3, then if I put a minus sign, minus x will be less than minus 3. Okay, see, just understand this concept very carefully. If you put up the minus sign, then the sign of inequality changes. Okay, if it is greater than over here, it will be less than over here. Okay. Okay, I take up one more example. Suppose I have x minus 5 is less than 0, right? That means x is less than 5, right? If I add a positive quantity both the sides, suppose 3, then I have to add the same number over here, a same constant over here to maintain the relationship. Okay, so if x minus 5 is less than 0, x will be less than 5. That means x plus 3 will be less than 8. Okay, similarly, if x is greater than 3, then if you multiply both the sides with a constant positive number, suppose 3 or maybe 4, so 4x is greater than 12. Okay, if the number is positive, no need to change the sign of inequality. If the number is negative, then you need to change the sign of inequality, right? Suppose x is greater than 3. So if you multiply both the side by minus 4, so what will happen? Minus 4x will be less than minus 12, right? So be very clear about the sign by which the sign of the number which is being multiplied on both the sides. Okay, so these are the simple concepts. When we'll be doing the problems, these concepts will be better cleared in your mind. Similarly, sometimes you get this sort of equations. Ax plus b by cx plus d is greater than k, maybe a constant number. K greater than equal to less than equal to, right? So one important thing over here you have to keep in your mind that in case of inequalities, never ever go for cross multiplication. Okay, if it is a constant term over here, then no problem, but if any variable is there on the right hand side, then never ever go for the cross multiplication. Okay, in case of solving inequalities, don't go for cross multiplication. And why I am telling this, I'll explain you later on. Suppose I have an expression x minus 3 upon x minus 2 is say greater than 2. Right? So how to solve this inequality? See, if it is greater than, equal to, less than or less than equal, that really doesn't matter. Just see the method, how do we solve it. Okay, what we do, we take to this side, x minus 3 upon x minus 2 minus 2 greater than 0. Okay, then as usual, just take LCM. X minus 3 upon x minus 2 minus 2 x minus 2 is greater than 0. Okay, now x minus 3 minus 2x plus 4 upon x minus 2 is greater than 0. X minus 2x, so that is minus x, minus 3 plus 4, so that is 1, upon x minus 2 is greater than 0. Okay, and if I wish to remove this minus sign, what I have to do, I multiply both the side with a negative number. So if I put a negative, multiply both the side with the negative 1, then the sign of inequality will be changed, right? So it is minus of minus x plus 1 upon x plus 2 will be in that case less than 0. And this is actually x minus 1 upon x plus 2 is less than 0. Okay, so just see it carefully step by step. I just repeat, x minus 3 upon x minus 2 is greater than 2. What I am doing, instead of cross multiplication, I am taking 2 to the left side, right? Because cross multiplication is not at all allowed in case of inequalities. You will miss out some of the calculations, so you have to be very careful about it. Okay, because see what happens, precisely what happens if you cross multiply this thing, right? So what you'll be doing, x minus 3 is greater than 2x minus 4. Okay, so it will be 2x minus x is less than 1. That means x is less than 1, right? You got this result. Okay, now x is less than 1. You got this. That is the only thing that you have concluded from this expression. But in this case, it is actually necessary that x is not equal to 2, because if x is equal to 2, you will be getting 0 in the denominator, right? So generally the students who go for the cross multiplication, they are not able to get this. Okay, they'll be just writing down the answer x is less than 1, but actually x should, whether it is less than 1 or not, that's a different thing, but x should not be equal to 2 in any case. Sometimes what will happen, you'll be getting the solution as x is greater than 1, and you'll be writing x is greater than 1. In x is greater than 1, x may be equal to 2 also, right? Not particularly in this case, maybe in some other case. So if x is greater than 1, so it can be 2 also, but x should not be equal to 2. That is a preliminary condition for existence of this expression, because if x is equal to 2, the denominator will be 0 and the expression will be undefined. Okay, anything divided by 0 is not at all defined. So be very clear and just keep this rule in your mind, that never ever go for the cross multiplication in case of inequalities. Okay, that's really important. We come back here. I multiplied minus sign, minus x plus 1. By mistake I write plus. It will remain minus. Okay, so by cross multiplying, I am getting x is less than 1. And if I do not go for the cross multiplication, I am getting x minus 1 upon x minus 2 is less than 0. So how do we solve this expression? That briefly I explained over here. It's I just put up the zeros of this, and this is 1 and this is 2. If you want this to be less than 0, that means x should be equal to between 1 and 2. That means x is greater than 1, less than 2. Okay. In this case, you are getting x is less than 1. In this case, you are getting x is greater than 1. So here we can see x lies between 1 and 2, and here we are getting x is less than 1, right? Now just listen to me carefully. the first thing that we missed is x is not equal to 2 over here, okay, by solving this method. The other thing is you just see x is less than 1, and here we are getting x is between 1 and 2, right? So if x is less than 1, suppose you take any value, x is less than 1, suppose x is 0. Now put 0 over here. What you will be getting? 0 minus 3, that is minus 3, upon 0 minus 2, that is minus 2. So what you will be getting? Minus 3 by minus 2, so precisely that is 3 by 2. Now 3 by 2 is greater than 2, so that's wrong. 3 by 2 is not greater than 2. Okay, so if you go for the cross multiplication, you will be getting wrong answer. You may get wrong answers also. Okay, but if you put any value between x between 1 and 2, suppose I put 1.5, so I'll be getting minus 1.5 by minus 0.5. So precisely 3 by 2 by 1 by 2, so I'll be getting 3, and that's actually greater than 2. Okay, so you understood the difference between the two. See, in this case we directly go for the cross multiplication. In this case we have taken the expression, the number, the site, and we are taking LCM and retaining the denominator. That is the most important part, because the denominator, if it is an equation or maybe an expression, or you can say variable is there, then it plays a major role. Okay, if it is a constant term, then no problem, but if it is a variable, an expression, then it will create a difference. Surely it will create a difference. Okay, so just be very clear about it. Do not go for cross multiplication in case of inequalities. And what I have done over here, I just solved this inequality using wavy curve method. This is wavy curve method. Okay, you just attend the third or fourth session of functions topic, you'll be able to understand this method very easily. Okay, and I'll attach the particular session over here also in this chapter linear inequations also, so you can understand how to solve inequalities with wavy curve method. Okay, so I'll see you in the next session once again. Bye bye.